Okay, so I did the elevator control system, um, and like I created a digital logic controller for an elevator, and the way the elevators work is that they uh, they only move with the destination depending on the user's input, and the door of the elevators is not open during motion, only open when reaching a destination or if a user presses a button to open the elevator. And the elevator can't move if the doors are not open. And this elevator is in a 10-story building. Uh, so the goal of this project is to implement a schematic of a digital logic controller for an elevator. And the diagram must take in 10 inputs, which are the floors of the building, and have the signal of the button pushed stay high until it reaches its destined floor. I have to implement clock cycles within the elevator, with the closing and reopening of the door lasting 5 clock cycles. The elevator travels at a speed of 3 clock cycles per floor. I must see that these conditions are met. Uh, when not in motion, the door to the elevator is open. A singular floor button uh, may be active at any time. Um, After the floor button is pressed, the door must close to proceed motion. Floor buttons and door buttons have no effect during motion, and after the elevator arrives to the destined floor, door opens, floor buttons are available again and ready for the next request. Uh, I have to be able to implement clock cycles within the elevator, and closing or opening of the door lasts 5 clock cycles, and the elevator travels at a speed of 3 clock cycles per floor. And so the main unit that I used for this was an encoder right here, uh, allowing multiple inputs, but only letting one of them be active. This allowing for like the floors to be selected. That active signal produces n-bit output signals containing the binary information. Using a BCD, uh, we're allowed to produce additional clock cycles and previous input data to gain a 4-bit output. Uh, and also additional gates used are the T and D flip flop right here and right here. These are used to keep keep signal going with the logic high and low, then stores it whenever the logic or whenever the signal is high. And so this is the schematic right here. Here are all the floor buttons, the encoders, the T and D flip flops, the BCD adder, and the door state, all the outputs. And so the circuit goes from left to right. It starts off with a 10 to 4 selector, which is for each floor. Only one of these can be active at any time. There are 4 outputs, so it produces the binary information of the selected logic high signals, the 4 outputs. All of the outputs are wired into their own T flip-flop. This allows the elevator signal to ride the clock edge and gives it 2 types of control over the state of the door. When the signal from the T flip-flop is high, it's stored into a D flip-flop. The stored signals in the D flip-flops will be used in the BCD adder for the final calculable binary outputs. And so the simulation results are right here. Right here. Um, I had a problem building like the BCD adder at first, but managed to figure it out. Initially, I used full adders, but it's way too big, and just in general, like I had to like do a reduction of what I was trying to do with like simpler things by using more complicated uh, things. And yeah, this is a really hard final project, and I think I learned a lot from this.